Once again, welcome to our chemistry class today. In our class today, we are going to be dealing with past questions in Jamb. And as I assured you before now, that if you keep on following this channel, you will not have any reason to regret because you get high score in chemistry this year. Yes, keep following. Without wasting time, let's go to questions. Question number 1. They have given me equation here. And they said, in the equation above, the equilibrium constant is given by A, they have given you this, B, they have given you this, C, they have given you this, D, they have given you this. Now, how do you get equilibrium constant in a reversible equation like this, equilibrium equation? Check the concentration of the product to the power of its mole ratio all over the concentration of the reactants to their own power. So if you check that, A starts with this, wrong. B is also starting with that, wrong. C is starting with G, concentration of G to the power of P, which is the mole ratio, yes. Concentration of H, this thing that we are writing like this is concentration. Concentration of H to the power of its what? Mole ratio, which is Q, all over the concentration of E to its own power and F to its own mole ratio. So this is correct, and this is not also correct. I hope you are following. Now let's look at number 2 questions. Number 2 question says, I, copper 2 oxide plus ammonia, giving you copper, water, and nitrogen. Ammonia with what? Chlorine gas. It gives you hydrogen chloride. It gives you nitrogen. Ammonia again with oxygen gives you this and this. Now the question follows, and the question says the reactions represented by the equations above demonstrate the A, basic properties of ammonia, B, acidic properties of ammonia, C, reducing properties of ammonia, D, oxidizing properties of ammonia. Now, where is ammonia? This is ammonia in this equation. This is ammonia in this equation. This is ammonia in this equation. Now, if you consider what ammonia does to this, and ammonia does to this, and ammonia does to this, you will now know what we are talking about. Okay, let's see the first equation. Copper 2 oxide. Now, after reacting with ammonia, it turns to what? Copper atom. It's a metal. Now, this was copper 2, and this is the oxidation number of copper here is 0. That means it's reducing. That means ammonia is reducing copper 2 to copper. Okay, let's check the second equation whether it will still be the same. What I mean, this is 2 plus and this is 0. It's reducing from 2 plus to 0. Now, ammonia here is reacting with this. This is oxidation number here is 0. Oxidation number of chlorine in this other side is -1. So it's also reducing. 0, remember that is bigger than -1. So it's reducing here. Let's see also in this place, ammonia reacting with oxygen. Oxygen here, oxidation number is also what? 0. So it's also 0. Now, oxygen in the product is -2. So from 0 to -2, it means that it's also being reduced. This is -2. So the work of ammonia in the 3 equation is to reduce those other substances. So it is used as what? A reducing agent. Okay, now let's check the options. Basic property, wrong. Acidic property, wrong. Reducing properties of ammonia, good. Oxidizing, wrong. So you can see the correct option there. I believe you are still following. Okay. Question number 3. The salt that reacts with dilute hydrochloric acid to produce a pungent smelling gas which decolorizes acidified purple potassium tetraoxomanganate 7 solution is A, this, B, this, C, and D. Okay, now the only salt among them that will produce a gas that will decolorize purple color of potassium tetraoxomanganate 7 is this. So this is the correct answer because SO2 will be produced with pungent smell. That's pungent smell. It's a gas with pungent smell, and it decolorizes potassium, purple color of what? Potassium tetraoxomanganate 7. Okay, I believe the class was interesting and you enjoyed the class. Keep following the channel. Keep sending or sharing the videos to your friends. Like the channel. Comment on. And let's see how you will not do well in your JAMB this year. Thank you.